Good morning, students. Welcome to Digital Learning Day 3. Today we will look at solving for a missing number in a proportion. I just wanted to take a second to say hello, and I miss y'all. Today you will need a pencil, paper, and your beautiful brain. As a reminder, every day you're going to go to Schoology and find today's folder, open it up, start at the top, and work down. You must complete things in order. Again, we will always start with attendance. Put your distractions away at the end of today's lesson. I want you to reflect on what you learned and what you still wonder about. Let's remember that a proportion in math are two equal fractions or ratios. A proportion is simply a statement that two ratios or relationships are equal. Again, we're looking at their cross products. In the real world, you might compare the length of a dog's back compared to the length of its muzzle. And you'll see in these two dogs that their relationship is equal because the cross products are both equal to 300. So we can actually say that these dogs are proportional. Today our learning target is that I will solve for a missing number in a proportion. Keep in mind that a proportion, again, is a statement that two ratios or relationships are equal, such as 3/4 and 6/8. Their cross products are 24 and 24. Therefore, they are equal. Today, we're going to be looking at how to find x, or a variable, and we will follow a procedure to set up an equation, a statement that two things are equal, which means the same even if they don't look it. Who uses this? Doctors use this to determine how much medication a person should get. I want to give a quick shout out to the first 30 students or so who answered the Google form yesterday. One of the things I wanted to point out is we have a couple students down here who said they were struggling, and I want you to ask yourself, how do I get help? As a reminder, you can always get a hold of me through Schoology. Send me an email and we can schedule a time to talk. Those of you who felt you were a little bit neutral on understanding, I would like you to think about what questions could you ask. This pie chart is just another display with the percentages of the whole. Yesterday, we were tasked with determining, are the fractions or ratios equivalent, and how can we tell? As a reminder, we're going to use cross products. 3 times 3 should be equal to 2 times 4. And in this case, 9 does not equal 8, so they are not equivalent. In the next example, are the ratios equivalent? We would get a cross product of 5 times 5 and 3 times 7. Does 25 equal 21? And the answer is no, they are not equal. Therefore, these ratios are also not equal. Okay, watch out for this one. Yesterday we had a kind of common confusion based around this. Many students said that these two, in fact, were equal when they are not. I believe that those students were looking at like a multiplication situation where they multiplied across. This is not the correct procedure. We would say 4/3, is it equal to 3/4? And when we determine the cross products, we would find that the cross products are 9 and 16. And since 9 does not equal 16, these are not equal. Oh, hey there, little guy. Again, another way to look at this fraction is greater than 1, and this fraction is less than 1, so they also cannot be equal. Let's remember to check our work. Oh, hey, SpongeBob. SpongeBob seems to be having a hard time understanding that 3y is equal to 246 because they don't look the same. But he's slowly becoming a believer. Even though it doesn't look the same, there is a number that would be multiplied by 3 that would equal 246. Now, everyone take a deep breath. I realize that for some of you this might be confusing. It's going to take a moment for you to think things through before your understanding takes off. We're going to use a procedure today of using cross products to solve for a variable. Now, some of you might know what W is just by looking, but we're going to find the cross products. 4 times 3, which should equal 2 times W. 4 times 3 simplifies to 12. 2 times W becomes 2W. Since we have an equation, we're going to use inverse operations, or opposite. So we see multiplication, so we're going to do division. So to undo the 2 that's being multiplied by W, we're going to divide both sides by 2. When we do that, we get 6 equals W. Therefore, W equals 6. What equation can you write from a proportion? Does it matter which number is missing? In our first example here, we're going to find the cross products of 3 times 4, which is equal to x times 6. So 12 should be equal to 6x. We'll solve this in the next step. What equation can you write for the second proportion? What are the cross products? The first cross product would be x times 2, which should be equal to, not should be, it is equal to, because we're told it's equal, which means exactly the same, 5 times 4, and then we're going to simplify. X times 2 would just be 2x. Remember, a number multiplied by a variable can be written without the multiplication symbol. And then 5 times 4 is equal to 20. Try the last one. Two times x is equal to 6 times 3. So 2x equals 18. So we know we're going to write an equation. How do we solve the equation? Again, the key to solving equations is inverse or opposite operations. And I want you to look for a pattern in how we solve it. Now, does our solution make a proportion? So let's look at that situation. So someone says, okay, I think I got this, and I think x is equal to 20. Is that correct? If we put 20 in, does it make a proportion? Does 5 times 8, 40, equal 20 times 2, 40? And the answer is yes. A student looked at the next problem and said, okay, I've solved it out, I showed my work, and I think x is equal to 8. So if we put x in as 8, does 24 equal 36? And the answer is no. So x is not equal to 8. So they went back and solved it again, and they said x is equal to 12. So we're going to ask, if x is 12, does this form a proportion? Does 36 equal 36? And the answer is yes. So our solution, the answer that makes this proportion true, is 12, and it checks out. Now, you're going to run into a situation where the numbers aren't friendly. But don't despair. In this last one, a student said, well, I think you're just adding 2 to get to the bottom. Okay, so let's see if that works. If we added 2, it'd get x equals 9. Does that work? If x is 9, are our cross products equal? Does 27 equal 35? And the answer is no. So in this situation, x was a decimal number of 11 and 6.6 repeating, or 11 and 6/10 repeating, 2/3. And 6/10 repeating. Bad kitty, I do what I want. I don't want that slide. All right, now let's put it all together. The steps to solving for a missing number in a proportion. First, we find the cross products, then we write an equation, we solve for the variable using inverse operations, and then we check to see if our answer makes a proportion. Keep calm and follow the rules. Again, look at this example to see the whole flow. So in our first one, 3 times 8 should equal x times 6. 24, x times 6 is 6x. We see multiplication, so we do division on both sides, and we get 4 is equal to x. If x is equal to 4, then 24 equals 24, and we're good to go. Okay, here we go. Find the cross products. The cross products would be x times 3, or 3x, is equal to 9 times 4. 3x is equal to 36. We see multiplication, so we do division, and x is equal to 12. If x is equal to 12, our cross products would be 36 and 36, so our answer is correct. In the last example here, keep calm. The answer is going to be a fraction or decimal number. Our first cross product would be 6 times x, which is equal to 8 times 5. Sorry about that. 6 times x is 6x is equal to 40. Now, there's no whole number that you can multiply to make 40. So we use our inverse operations. We see multiplication. We do division. And x would equal 40 divided by 6. So x is equal to 40 divided by 6, which is 6 and 2/3, or 6.6 repeating. Again, a common confusion is some students think that x is equal to 3 because they just add to the numerator and denominator. They say, well, I see you add 1 to get to 4, so I add 1 to get to 3. But again, we have to be very careful. This is one of the main goals of today's lesson, is to understand that 3 is not a solution, because the cross product 8 does not equal the cross product of 9. 9 does not equal 8, so 3 is not a solution. You made it. The end. Our next step will be to use this when we have a real-life situation, so stay tuned for ratio boxes. Ratio boxes will be an organized way to establish a proportion and then solve.